for this next example, it's given us that given z equals to e to the I theta or cos theta plus I sin theta, show z squared minus 1 upon z squared plus 1 equals to I tan theta. So there's two methods to do this question. One's like relatively straightforward, and the other one involves a little bit of work. So we'll start with method 1. This says z squared minus 1 upon z squared plus 1. Another way of writing this can be z minus 1 upon z plus 1 upon z. That's the same way as writing z squared minus 1. So we can rearrange this into z minus z to the negative 1 upon z plus z to the negative 1. Now we've got that. In the previous example, we had something similar to this. So this is basically De Mor's theorem, where it suggests that z to the n minus z to the negative n is just 2I sin theta, like we developed in the previous example. So we can rewrite this as z, or we can sub it in first to make it a little easier. E to the I theta minus e to the I, in this case negative I theta, upon e to the I theta plus e to the I, negative e to the I theta. So we can, this then, the top then becomes 2I sin theta upon, the bottom is just 2 cos theta. This is purely imaginary, this is purely real. 2 cos theta, which then you cancel out the 2's, and I sin theta upon cos theta is tan theta, which then equals to I tan theta. So that's method 1. So we can go about solving this question. Let's look at method 2 now. That's using this situation right here. So we've got that z squared minus 1 upon z squared plus 1. Let's just sub that into this. So we go bracket cos theta plus I sin theta all squared upon, sorry, we've got the minus 1 upon cos theta plus I sin theta all squared plus 1. Now we can expand these right here. So we go cos squared theta, I'll just do it over here. Go cos theta plus I sin theta. Expand that, we go cos squared theta plus I cos theta, I sin theta cos theta plus I sin theta cos theta. So we get 2 plus 2 I sin theta cos theta. This is a very important thing right here. And then we've got sin squared theta, I squared is just negative 1, minus sin squared theta. So now we've got that, we've developed that. Let's bring out, so we know that this equals to that, so let's just put that there, and we'll separate the real and the imaginary terms together. So we get cos squared theta minus sin squared theta plus, if you recognize this from extension 1 maths, where you've got your trig identities, 2 sin theta cos theta is sin 2 theta. That's the double angle formula right there. So we've got plus I sin 2 theta, and 1 is basically cos squared theta plus sin squared theta plus cos squared theta equals to 1. That's another identity you got to remember. You can just sub that in. So sin squared theta, so we can go minus brackets sin squared theta plus cos squared theta right there. So now we've got this, and do the same for the bottom, except this then becomes cos squared theta right here. So this just stays the same, minus sin squared theta plus I sin 2 theta, but instead of the plus we just have plus 1 here, plus sin squared theta plus cos squared theta. So now we can further simplify the top that becomes, we can get, so that becomes sine squared and this becomes minus there. Get rid of the brackets, make it a bit easier instead of rewriting it again. So that and that cancel, this and this. So the bottom then becomes, cancel, cancel, gone, we have minus 2 sine squared theta, minus 2 sine squared theta, plus I sine 2 theta, all upon, we'll rewrite this as sine 2 theta right here, all upon, the bottom then becomes 2 cos squared theta plus 2I sine 2 theta. What can we do next? So this is a 2 right here. 2I sine 2 theta. So the next part right here, the negative 1, we can change that to I squared. So this then becomes 2I squared sine squared theta plus 2I sine theta cos theta all upon 2 cos squared theta plus 2I sine theta cos theta. So what can we change right here is we can factor out the 2I on both sides. The bottom then becomes 2I sine theta brackets cos theta plus I sine theta. And the bottom, same thing, 2 cos theta brackets cos theta plus I sine theta, which then equates to cancel, 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 sine theta cos theta becomes tan theta, which is just I tan theta. So this is method 2 in order to solve this question right here. Thank you so much for watching my video. I'll see you in the next one.